Hello, pre-algebra. Welcome to lesson 6.3, beginning on page 145, which I did not write down, and I'll do that right now. Page 145, and we will be looking and learning information through page 148. Okay, we're going to start with vocabulary. When determining speed, we first have to realize what it is. Speed is always written as a fraction, where you put the distance traveled over the time taken. Now, uniform or constant speed is speed that never changes over a period of time, so that speed never fluctuates. As you noted, this rarely happens because sometimes you speed up and you slow down, so sometimes it just goes differently. So this is a very isolated laboratory setting, for example. So because this rarely happens, we often find average speed, which again is the total difference covered over the total time taken. So sometimes the distance varies one way opposed to the other, so you add them together, and then sometimes one way takes a little bit more time than the other, and then you add those together, and then you actually go back to doing what the speed formula does. You just write it like a fraction, figure it out, and that gives us average speed. So, keeping all those little vocabulary terms in mind, we're going to begin with Triad 11 at the top of 147. Triad 11 says the average speed of a car for the first 1.5 hours of a journey is 64 miles per hour. Its average speed for the next 2.5 hours is 72 miles per hour. Find its average speed for the whole journey. Well, in order to do that, I have to see how far he traveled in the first 1.5 hours, which is 64 times 1.5 hours, because it's 64 miles an hour, so I multiply the two. And to that, I'm going to add the second part of the journey, which is 72 miles per hour times the 2.5 hours traveled. When I do that, 64 times 1.5 is 96. And to that, I'm going to add 72 times 2.5, which is 180, which gives me a total distance of 276 miles. Now I got to go back and use parts of that to see how much time did it take him to do this. Well, again, I'm going to use 1.5 hours plus 2.5 hours, which is 4 hours. Now I can put those two figures into the fraction I need. So total distance covered is 276 miles. Total time taken was 4. So I'm going to divide those two. I come up with 69 miles per hour as my average speed for this journey. Okay. Remember, you can pause and think things through. If you have questions, make sure you ask. But let's continue now to Triad 13. Triad 12. Not at 13 yet. Triad 12, and I'm going to just get this back into the frame. I think we're good. Okay, so Triad 12 is at the bottom. It says in Triad 12, towns X and Y are 108 kilometers apart. Susan drives at an average speed of 72 kilometers per hour from X to Y, and then returns from Y to X, so same distance, 108 kilometers. But when she returns from there, her average speed is 54 kilometers per hour. Find her average speed for the whole journey. Well, first of all, the total distance travel, it's 108 one way and then 108 back, so it's 216 kilometers, so that's the whole distance traveled. And the total time that she traveled, well, it was 108 kilometers at 72 kilometers per hour, and then that same 108 at 54 kilometers per hour. So I'm going to figure those two things out and add them together. So when I divide 108 by 72, I have 1.5. And when I divide 108 by 54, it's 2. So 1.5 plus 2 is 3.5 hours. So I take my total distance traveled, 216 kilometers, over the total time, which is 3.5. At this point, my answer is 61 and 5/7 kilometers per hour. Note on your calculators, when you divide, like with a decimal, or which is what you would want to divide with on your calculator, you're going to come up with a bunch of things. Just convert it into a fraction at that point and see what you get, and you would have 5/7. All right, continuing on, top of the next page, we have Triad 13, which reads, the speed limit for a road is 80 kilometers per hour. Letter A says express the speed limit in meters per second. So now we have to do some conversion of units. And then letter B says taking 1 kilometer equaling 0.62 miles, express the speed limit in miles per hour. Okay, so we're doing a bunch of conversions here. So they give us the rate. The speed limit is 80 kilometers per hour. I'm going to change kilometers into meters, which is what they want. And there's 1,000 meters in a kilometer, and they want meters per second. There's 3,600 seconds in that hour. So I'm changing kilometers. 1 kilometer is 1,000 meters, and then 1 hour is 3,600 seconds. That's what I got to change it to. So it's 80, and if you 80 per 1 hour is like 80 over 1, so you just don't need the 1. So it's 80 times keeping your kilometers, your meters across from your kilometers, 1,000. And since the hour is down here, that's worth the seconds, 3,600. You do your crosses and you do your reductions, and you're going to get some sort of wonky decimal, change it to a fraction. You get 22 2/9 meters per second. Going on to B. Now you go back to the original speed limit. And there in B, remember it says taking 1 kilometer equaling 0.62 miles, express the speed limit in miles per hour instead of kilometers per hour to the nearest 10 miles per hour. Okay. So you're going to do some rounding. So you're going to take the kilometers and just multiply it by the conversion because they gave it to you. So 80 times 0.62 miles per hour, that's given because this part is the given part, ends up being 49.6 miles per hour. So I need to round it to my nearest tenth, which is 50. So 50 miles per hour is my answer for letter B. Continuing with conversions. Okay, one more time to see if I'm in frame. It's going to take me a while to get used to this new thingamajig. Okay, all righty. So 14 reads, the pronghorn antelope. What in the world is a pronghorn antelope? Huh. Must be a hunter's dream or something. I have no. Anyway, the pronghorn antelope's exceptional speed is necessary in order to evade predators by outrunning them. The animal is considered to be the fastest land animal in the United States. Well, how about that? Interesting. Anyway, we haven't even gotten to the math part yet, but I like the first part. Anyway, the next part says the top speed is very difficult to measure accurately. Well, I would imagine because he's going so fast. However, the animal has been clocked at 61 miles per hour. Ding, 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 ding. And there it is, 61 miles per hour. Now we want to express this speed in kilometers per hour. Well, in the problem above in Triad 13, we found out 1 kilometer is equal to 0.62 miles. We're going to use that information. So 61 miles per hour times, since we're going backwards, we're going to do the we're going to do the fraction of that. So 1 over 0.62. We'll change this into kilometers per hour. So I just get rid of all those initials and rewrite it. 61 times 1 over 0.62, which is 61 over 0.62. I would just enter this into my calculator, 61 divided by 0.62, and it comes out to 98.39. And it's probably some more things afterwards because the book says you got to round it to this place. The reason we round it to 2 decimal points is because we're dividing it by something that has 2 decimal points. So our final answer is 98.39 kilometers per hour. There you have it. Remember, you can pause, stop, rewind, rewatch as often as necessary to understand the basic concepts. I think the conversion of units may be a little bit tricky. You may use your Chromebook to find out how many of something is in another thing if you need to. That is always a good source to look things up on. I will be giving you your assignment in class, so do good math, and remember, if you have any questions at all, be sure to ask. Thank you.